So, as I have said in this video, we'll do the tutorial. And maybe let me not split the screen into two. And so here, the example of the tutorial. Okay. And the question says the following: find the inverse of the matrix 1 2 0 2 minus 1 0 3 1 2. We are asked to find the inverse of that matrix. So how do we do that? The easiest way is going to be this. We have seen it in the lecture here. You just write the augmented matrix RH on the left hand side and the identity matrix on the right hand side, and you perform Gauss-Jordan eliminations on the augmented matrix, and then at the end you will end up with an identity matrix on the left, and whatever matrix you have on the right is your inverse. Okay, so let me start. Okay, so here it is. We have our matrix 1 2 0 2 minus 1 0 3 1 2. Okay, let me write that 0 0 there, and there I write the identity matrix 1 0 0 0 1 0 0 0 1. Okay, and we perform Gauss-Jordan. So basically I want to use the 1 here to be able to eliminate the 2 in the 1 in the first row here. I want to use that one there to be able to eliminate. I'm sure you know how to do Gauss-Jordan. So if you don't recall, have a look at the first chapter of these recordings, and we have done plenty. Okay, so in this tutorial I'm going to fly through how to perform Gauss-Jordan eliminations. Okay, I assume you know how to do it. If you don't, maybe pause and go and have a look at my chapter 1, linear systems. Okay, and come back to have a look at the rest of the video. So we have here minus 2 row 1 plus row 2. Should be able to cancel the 2 in row 2, so you have 1 2 0 for row 1, and on the right hand side we have 1 0 0. We haven't done anything to row 1, but here for the row 2 we have 0 here, minus 2 minus 1 is minus 5, here is 0, here we have minus 2 is 1, so identity here we have 1 there, 1 and 0 there. When it comes to the third row, I'm going to multiply row 1 by minus 3 and add it to row 3. Okay, so I'm going to be left with the 0 here, minus 6 plus 1 is minus 5. Here we have a 2 minus 3 plus 0 is minus 3. This is 0 and this is 1. Okay. And minus row 2 plus row 3. Okay, so here I'm going to have minus row 2 plus row 3 to be able to cancel that minus 5 in row 3. So 1 2 0 1 0 0, and here we have 0 minus 5 0 minus 2 1 0, and here 0 0, and I'm left with the 2 here. So here minus plus is 2 minus 2. I'm doing row 2 minus so here I'm doing minus I'm doing minus row 2 plus row 3, so I'm left with minus 1 here, here as well, minus 1, and 1 there. Okay, so I'm going to continue here. What I'm going to do here is to divide row 2, I want to have 1 in the diagonal, so I'm going to have minus 1 over 5 row 2, and then I also want to divide row 3 by a half row 3. This will give us 1 2 0 1 0 0 0 1 0, and here is going to be 2 over 5 minus 1 over 5 and 0, and 0 0 1, and here we have a half, so we have minus a half, minus a half, and a half. Okay, so now let's go to the last phase. I want to use the 1 here to cancel the 2 in row 1. So I'm going to do minus 2 times row 2 plus row 1. Okay, so let me recopy row 3, 0 0 1. We have minus a half, and a half there, and 0 1 0, row 2 is unchanged, 2 over 5 minus 1 over 5 is 0, and here we have 1 2, sorry, the purpose here is to eliminate these two, so it's going to be 0 0 0, and here if I have 2, okay, so I'm left with the 1 over 5 here, so I have minus 2 times row. Okay, let me have here minus 2 times row 2, so minus 4 over 5 plus plus 1 is 1 over 5 there, and here I have minus 4 over here is going to be 2 over 5, so here is going to be 2 over 5 here. Okay, and here is going to be 0. Okay, so we end up with here the identity here, and here is our H inverse. Therefore the inverse, okay, the inverse of our matrix H, let me write it fully. Therefore 1 2 0 2 minus 1 0 and 3 1 2, the inverse of this matrix is 1 over 5 2 over 5 and 0 2 over 5 minus 1 over 5 0 minus 1 over 2 minus 1 over 2 1 over 2. Okay, okay, so I think we just can stop it here. This is not a very long tutorial, and we will continue next video with the lecture. We will start a new part 5 of this chapter. We will start talking about the change of bases. Very interesting topic as well. Okay, see you. Bye.